So originally we understood the approximate size of an atom, and we understood also that it contained positive and negative charged particles called protons and electrons. And the original model was sometimes referred to as the plum pudding model. And in this model, essentially, the charges were just sort of interspersed around like a plum pudding, or I guess like a grape muffin. And then you had electrons kind of inside, and then you had protons inside too. And it was all sort of spread out in sort of something on the order of 10 to the minus 10 of a meter, which is the approximate diameter of an atom. In 1910, a scientist by the name of Rutherford did an experiment, or rather directed an experiment. And in the Rutherford experiment, what they did is they took a very thin film of gold that turned out just to be a few atoms wide, and an alpha particle emitter, so a radioactive emitter, was placed in a cube of lead with a pinhole cut out. So essentially these very positive radioactive particles could move through in a straight line. And what was expected to happen is that the gold was very thin, the film was just a few atoms wide, and these particles, which were sort of like atomic cannonballs, were expected just to go right on through to the other side. And in fact, most of them did go through to the other side. And the reason that was known was that this film here was coated with zinc sulfide that actually fluoresces when these positive particles hit it. What was not expected, though, is that there are a small percentage of particles that are deflected to a reasonable angle, and an even smaller percentage that actually sort of backscatter and deflect and come almost back at the original emitter. This was thought to be very weird, because imagine firing a cannonball at a piece of wet toilet paper. You would be extremely surprised even if 1 in 10,000 cannonballs came careening back towards you as they bounced off the toilet paper. You would just expect all of them to shred right through the paper. So this led to a model of the atom then that had to account for these details. And the way the model was developed was that it was understood that most of the mass of the atom was present in a very, very tiny small spot in the center that we call the nucleus. And the nucleus is where all the protons and the neutrons are that make up 99% of the mass of the atom. And the outside of the atom is really just this whiffy, fluffy cloud of electrons. And so this electron cloud on the outside. And the reason this helped to explain is that as the alpha particles, these large positive particles, move through the atom, most of the time they just hit the electron cloud and they just pass right through. The electrons are thousands of times less heavy than the alpha particles. They offer no resistance at all. But of course, every now and again, one of those particles strays close to the nucleus, and maybe it undergoes a glance-in blow, so it's deflected to an angle. But only in the case of a very, very lucky hit does it hit straight on and ricochet back at a very tight angle. And so most of the time you don't see this, but every now and then you see this, and this is sort of conclusive evidence that most of the weight of the atom and most of the charge of the atom is kind of squished into a very, very small volume we call the nucleus, which actually stands for little nut, believe it or not.